Hi guys, let's continue to talk about reinforcement learning algorithm. So we should deep into this problem, and today let's discuss about normalized dataset. For neural network, it's very important to do standardization of dataset or something like standard scalar, min-max scalar, or some normalization data. It's different another techniques for normalizing data is important. And in this case, we should normalize two features. The first feature would be normalize our dataset. In our case, we used last 50 bars to make some decision using reinforcement learning, and we should do analyze this environment state. Also, we should to do normalize of reward, because it's also important when we do some normalize of reward function, because sometimes we get a big reward, sometimes we get some small reward. And if you will do this normalization of dataset, we could achieve better results. This is a tensor board from models, last model what I trained, and you see, for example, tensor board logs PPO7 is the last model what I trained, and the most important for us is mean reward. And you see, our mean reward is increase each time step, so it makes sense. Train more time. In this case, we see some loss function, but I would like to show you some compare of previous models what we developed. For example, you see with our folder reinforcement learning, new file would be normalize env, but previous was, for example, multiprocessor. Yeah. And when I use this model, let's look at, for example, this one and run, and you see we couldn't achieve some good mean rewards. And when we wait a long time when algorithm is trained, and we couldn't achieve some increase of mean reward function. But in this case, if we run it is more than 2 millions for 1100 timestamp, we could achieve this reward. Okay, it means we could increase our results of reinforcement learning. So what we should to do, let's look in. So this is the same new class. What we import would be vec normalize. You see this one. Another would be the same. Let's delete it. It's not important. Numpy also. And we download data for the, for example, the last 1 month. We do the same data processing, rename columns. Next one, we need to define logdir. This would be our temp file when I'm going to save environment with normalization data and our model. This would be our environment in Windows size. We're going to analyze last 50 bars, and we create an environment. It's the same. Let's look in. Also, I'm going to use nom-CPU. It means we do some multiprocessing. In my laptop I have 6 CPU, and it will be 6 environment. For each processor would be 1 environment, and you could achieve some results using this approach. Okay, new knowledge for you would be to use vec normalize, and we use this wrap class, and you see we input this environment into this wrap class, and indicate this normalized observation. It means your state would be true, and normalization reward also should be true. Okay, this would be the most important feature, and when we use it, we could achieve better results than before. This is simple, but we could solve reinforcement learning problem in this case. To display TensorBoard dashboard, you should use TensorBoard logs. And you see, for example, you could indicate some folder to store these logs. In my case, I used this folder, TensorBoard logs, and I store 7 models because I'm running it multiple times using different approach to show you that we could achieve better results. You see, mean reward is increased. Okay, next one, what we should do, we should save our model, and also we could save our environment, because our environment has some coefficient to normalize our dataset. We should use it. For testing models, we should use this approach. So we create our environment and indicate also seed, because I would like to reproduce results, and number of CPU. We create this default of environment, and we do wrapper. We used coefficient from back normalize to normalization of our dataset. Next one, for production, you should include train false, and normal reward also should be false. Next one, you should to load our model, what we said before. In our case was PPO, this model I said, and input our environment. You see, this environment, this would be a wrapper environment using vector normalization. Okay, this is simple. Next one, you should test our model and identify what happens. Okay, we run loop while, and we declare results. Results will be empty list, and we run this loop and identify action state. Okay, but when we do prediction of this observation, what does it mean? Observation of this model would be 6 different observations, because I have num CPU is 6 here, I mean. So when I predict this action, it means I predict action for this 6 environment, and this is the same. So we get 6 different reward from 6 different environment. Okay, and I would like to store these results in this dictionary. I used this loop. It means it would be environment, number of environment, because I'll loop enumerate. It would be like number. For example, 0, 1, 2, 3, 4, 5 would be 6 different environment, and indicate total profit. And we append these results to our empty list. And next one, when we're done this environment, when we loop all observation, we break this loop and create pandas data frame. Okay, when we did it, so let's plot results. For example, last 1000 point, and you see we increase. It's better than before. For example, when we see these results, when we render, when we did some render, it takes a long time, and you see this method when I used before, I achieve negative total reward, and I wait is about 30 minutes, and I achieve only 6% profit, and the total reward is negative. It means I couldn't achieve some positive results using this approach. And when I run several times, each times I get different results. So it's not working. I couldn't achieve some nice results, and you see, because my mean reward was is about 0, so I couldn't train it with this one. But when I did normalization, I test 6 environment in one time, and you see we have the similar results. Our profit line is increased. We have some range of our profit lines, for example, upper band, lower band, and in general we could say that it's working. For example, you could run 1000 environment and you get the similar results. Means you get some range of these results, but your results would be like increase profit line. Yeah. Next one, for example, I used this extend pandas. It means from quant stats to analyze our profit. And you remember we have very bad results with drawdown. Sometimes we have a very long period for drawdown. This is about 1 month. Let's look at this one, for example. Yeah, like this one. You see we have very big drawdowns. It's not fine for our profit line. It's not good. Okay, but in this case, when we did normalization of data, my drawdown is less than 1 day, and you see, and drawdown is about 2%. Okay, so of course we have some problem with overfitting here, but compare of these results, which are better results, because here we have some bad results and very big drawdowns. It's about 2 months, and when we test only 3 months, it's not good for us. But normalization, when we use normalization, we achieve better results. So guys, you could test it and improve your trading experience, and we're going to continue to make our knowledge deeper in reinforcement learning. And if you like this video, subscribe on my YouTube channel, and see you next time. Bye.